AIX is a series of proprietary Unix operating systems developed and sold by IBM for several of its computer platforms. Originally released for the IBM 6150 RISC workstation, AIX now supports or has supported a wide variety of hardware platforms, including the IBM RS/6000 series and later POWER and PowerPC-based systems, IBM System I, System/370 mainframes, PS/2 personal computers, and the Apple Network Server. AIX is based on UNIX System V with 4.3 Bahamian dollars compatible extensions. It is one of 5 commercial operating systems that have versions certified to the Open Group's UNIX 03 standard. The AIX family of operating systems debuted in 1986, became the standard operating system for the RS/6000 series on its launch in 1990, and is still actively developed by IBM. It is currently supported on IBM Power systems alongside IBM I and Linux. AIX was the first operating system to utilize journaling file systems, and IBM has continuously enhanced the software with features like processor, disk and network virtualization, dynamic hardware resource allocation, and reliability engineering ported from its mainframe designs. History. AIX version 1, introduced in 1986 for the IBM 6150 RT workstation, was based on UNIX System V releases 1 and 2. In developing AIX, IBM and Interactive Systems Corporation also incorporated source code from 4.2 and 4.3 Bahamian dollars Unix. Among other variants, IBM later produced AIX version 3, based on System V release 3, for the Power-based RS/6000 platform. Since 1990, AIX has served as the primary operating system for the RS/6000 series. AIX version 4, introduced in 1994, added symmetric multiprocessing with the introduction of the first RS/6000 SMP servers and continued to evolve through the 1990s, culminating with AIX 4.3.3 in 1999. Version 4.1, in a slightly modified form, was also the standard operating system for the Apple Network Server systems sold by Apple Computer to complement the Macintosh line. In the late 1990s, under Project Monterey, IBM and the Santa Cruz operation planned to integrate AIX and UNIXware into a single 32-bit/64-bit multi-platform Unix with particular emphasis on running on Intel IA64 architecture CPUs. A beta test version of AIX 5L for IA64 systems was released, but according to documents released in the SCOV IBM lawsuit, less than 40 licenses for the finished Monterey Unix were ever sold before the project was terminated in 2002. In 2003, the SCO Group alleged that IBM had misappropriated license source code from UNIX System V Release 4 for incorporation into AIX. SCO subsequently withdrew IBM's license to develop and distribute AIX. IBM maintains that their license was irrevocable, and continued to sell and support the product until the litigation was adjudicated. AIX was a component of the 2003 SCOV IBM lawsuit, in which the SCO Group filed a lawsuit against IBM, alleging IBM contributed SCO's intellectual property to the Linux codebase. The SCO Group, who argued they were the rightful owners of the copyrights covering the Unix operating system, attempted to revoke IBM's license to sell or distribute the AIX operating system. In March 2010, a jury returned a verdict finding that Novell, not the SCO Group, owns the rights to Unix. AIX 6 was announced in May 2007 and ran an open beta from June 2007 until the general availability of AIX 6.1 on November 9, 2007. Major new features in AIX 6.1 included full role-based access control, workload partitions, enhanced security and live partition mobility on the POWER6 hardware. In April 2010, IBM published an announcement about the upcoming 7.1 release. Support is planned to continue on POWER4 later hardware generations. Several new features, including better scalability, enhanced clustering and management capabilities are mentioned. The ability to run older versions of AIX as a WPAR keeps the opportunity to continue using 5.2 where the hardware doesn't support it. IBM intends to make 7.1 available with an open beta program again. Supported hardware platforms, IBM 6150RT. The original AIX was developed for the IBM 6150RT workstation by IBM in conjunction with Interactive Systems Corporation, who had previously ported UNIX System 3 to the IBM PC for IBM as PC9. According to its developers, the AIX source consisted of 1 million lines of code. Installation media consisted of 8 1.2M floppy disks. The RT was based on the ROMP microprocessor, the first commercial RISC chip. This was based on a design pioneered at IBM Research. One of the novel aspects of the RT design was the use of a microkernel, called Virtual Resource Manager. The keyboard, mouse, display, disk drives and network were all controlled by a microkernel. One could hotkey from one operating system to the next using the Alt-Tab key combination. Each OS in turn would get possession of the keyboard, mouse and display. Besides AIX V2, the PIC OS also utilized this microkernel. Much of the AIX V2 kernel was written in the PLI programming language, which proved troublesome during the migration to AIX V3. AIX V2 included full TCP/IP networking, as well as SNA and two networking file systems, NFS, licensed from Sun Microsystems, and distributed services. DS had the distinction of being built on top of SNA, and thereby being fully compatible with DS on the IBM mid-range AS/400 and mainframe systems. For the graphical user interfaces, AIX V2 came with the X10-3 and later the X10-4 and X11 versions of the X Window system from MIT, together with the Athena widget set. Compilers for Fortran and C were available. One of the more popular desktop applications was the PageMaker desktop publishing software. IBM PS/2 series. AIX PS/2 was developed by Locus Computing Corporation under contract to IBM. AIX PS/2, first released in 1989, ran on IBM PS/2 personal computers with Intel 386 and compatible processors. The product was announced in September 1988 with a baseline tag price of $595, although some utilities like Aix were included in a separate extension package priced at $250. NROFF and TROF for AIX were also sold separately in a text formatting system package priced at $200. The TCP/IP stack for AIX PS/2 retailed for another $300. The X Window package was priced at $195, while the C and Fortran compilers each had a price tag of $275. Locus also made available their DOS Merge virtual machine environment for AIX, which could run MS-DOS 3.3 applications inside AIX. DOS Merge was sold separately for another $250. IBM also offered a $150 AIX PS/2 DOS server program, which provided file server and print server services for client computers running PC DOS 3.3. The last version of PS/2 AIX is 1.3. It was released in 1992 and announced to add support for non-IBM computers as well. Support for PS/2 AIX ended in March 1995. IBM mainframes. In 1988, IBM announced AIX/370, also developed by Locus Computing. AIX/370 was IBM's third attempt to offer Unix-like functionality for their mainframe line, specifically the System/370. AIX/370 was released in 1990 with functional equivalents to System V Release 2 and 4.3 Bahamian dollars as well as IBM enhancements. With the introduction of the ESA/390 architecture, AIX/370 was replaced by AIX ESA in 1991, which was based on OSF/1, and also ran on the System/390 platform. This development effort was made partly to allow IBM to compete with Amdahl UTS. Unlike әiʔ/370, AIX ESA ran both natively as the host operating system, and as a guest under VM AIX ESA, while technically advanced, had little commercial success, partially because UNIX functionality was added as an option to the existing mainframe operating system, MVS, which became MVS ESA Open Edition in 1999. PowerPC-based systems. The release of AIX version 3 coincided with the announcement of the first POWER1-based IBM RS/6000 models in 1990. The RS/6000 was unique in that it not only outperformed all other machines in integer compute performance, but also beat the competition by a factor of 10 in floating-point performance. The competition consisted of UNIX workstations from the vendors Sun, HP and SGI, and, to a lesser degree, those from Intergraph and others. The machines were all roughly comparable, retailing in the $10K to $100K price range, and offering similar amounts of RAM, disk and networking, and roughly comparable graphics subsystems. The novelty of the floating-point unit was that it was tied into the integer pipeline, and performed a single multiply-add instruction per cycle. The common wisdom of the era was that only integer performance mattered, oddly belying the fact that many customers were running floating-point intensive numeric scientific computing workloads. Releases of AIX version 3 also took advantage of the developments in the Power architecture. Aix V3 innovated in several ways on the software side. It was the first operating system to introduce the idea of a journaling file system, JFS, which allowed for fast boot times by avoiding the need to ensure the consistency of the file systems on disks on every reboot. Another innovation was shared libraries, which avoid the need for static linking from an application to the libraries it used. The resulting smaller binaries used less of the hardware RAM to run, and used less disk space to install. Besides improving performance, it was a boon to developers. Executable binaries could be in the tens of kilobytes instead of a megabyte for an executable statically linked to the C library. AIX V3 also scrapped the microkernel of AIX V2, a contentious move that resulted in V3 containing no PLI code and being somewhat more pure than V2. Other notable subsystems included IRISGL, a 3D rendering library, the progenitor of OpenGL. IRISGL was licensed by IBM from SGI in 1987, then still a small company which has sold only 1,000 machines to date. SGI also provided the low-end graphics card for the RS/6000, capable of drawing 20,000 Gouraud shaded triangles per second. The high-end graphics card was designed by IBM, a follow-on to the mainframe-based IBM 5080, capable of rendering 990,000 vectors per second. PHIGS, another 3D rendering API, popular in automotive CAD CAM circles, and at the core of CATIA, full implementation of version 11 of the X Window system, together with Motif as the recommended widget collection and window manager. Network File Systems, NFS from Sun. AFS, the Andrew File System. And DFS, the Distributed File System. NCS, the Network Computing System, licensed from Apollo Computer. DPS on-screen display system. This was notable as a Plan B in case the X11 plus Motif combination failed in the marketplace. However, it was highly proprietary, supported only by Sun, Next, and IBM. This cemented its failure in the marketplace in the face of the Open Systems challenge of X11 plus Motif and its lack of 3D capability. As of 2011, AIX runs on IBM Power, System P, System I, System P5, System i5, eServer P5, eServer P Series and eServer O5 server product lines, as well as IBM Blade Center blades and IBM PureFlex compute nodes based on Power architecture technology. POWER7 AIX features, performance optimization with enhanced RISC version 7 enables a unique performance advantage for AIXOS. POWER7 features new capabilities using multiple cores and multiple CPU threads, creating a pool of virtual CPUs. Typically IBM POWER7 processors have 8 cores with 4 threads per core, for a total capacity of 32 simultaneous threads or 32 virtual CPUs per processor circuit, while still using the same electricity consumption as the POWER6 processor circuit, which could only support 8 virtual CPUs. AIX can harness POWER7's ability to execute instructions out of order instead of in order, by using POWER7's aggressive out-of-order instruction set, which drives highly efficient use of available execution paths. AIX7 includes a new built-in clustering capability called Cluster Aware Aix. AIX is able to organize multiple LPARs through the multipath communications channel to neighboring CPUs, enabling very high-speed communication between processors. This enables multi-terabyte memory address range and page table access to support global petabyte shared memory space for AIX POWER7 clusters, so that software developers can program a cluster as if it were a single system, without using message passing. AIX administrators can use this new capability to cluster a pool of AIX nodes. By default, AIX v7.1 pins kernel memory and includes support to allow applications to pin their kernel stack. Pinning kernel memory in the kernel stack for applications with real-time requirements can provide performance improvements by ensuring that the kernel memory and kernel stack for an application is not paged out. AIX POWER7 systems include the active memory expansion feature, which increases system flexibility where system administrators can configure logical partitions to use less physical memory. For example, an LPAR running AIX appears to the OS applications to be configured with 80 GB of physical memory, but the hardware actually only consumes 60 GB of physical memory. Active memory expansion employs memory compression technology to transparently compress in-memory data, allowing more data to be placed into memory and thus expanding the memory capacity of POWER7 systems. Utilizing active memory expansion can improve system utilization and increase a Systema Euro-1 registered trademark S throughput. AIX7 automatically manages the size of memory pages used to automatically use 4K, 64K or a combination of those page sizes. This self-tuning feature results in optimized performance without administrative effort. Apple Network Servers. The Apple Network Server systems were PowerPC-based systems designed by Apple Computer to have numerous high-end features that standard Apple hardware did not have, including swappable hard drives, redundant power supplies, and external monitoring capability. These systems were more or less based on the Power Macintosh hardware available at the time, but were designed to use AIX as their native operating system in a specialized version specific to the ANS. AIX was only compatible with the network servers and was not ported to standard Power Macintosh hardware. Not to be confused as AUX, Apple's earlier version of Unix for 68K-based Macintoshes. IA64 systems. As part of Project Monterey, IBM released a beta test version of AIX5L for the IA64 architecture in 2001, but this never became an official product due to lack of interest. Versions. PowerPC releases, AIX v7.1, September 10, 2010. Support for 256 cores/1024 threads in a single virtual machine. The ability to run AIX v5.2 or v5.3 inside of a workload partition, an XML profile-based system configuration management utility, support for export of fiber channel adapters to WPARs, VIOS disk support in a WPAR, Cluster Aware Aix, AIX event infrastructure, role-based access control with domain support for multi-tenant environments. AIX v6.1. November 9, 2007. Workload partitions, operating system level virtualization, live application mobility, live partition mobility, security, role-based access control RBAC, AIX Security Expert, a system and network security hardening tool, encrypting JFS2 file system, trusted AIX, trusted execution. Integrated Electronic Service Agent, TM, for auto error reporting, concurrent kernel maintenance, kernel exploitation of POWER6 storage keys, probe view dynamic tracing, systems director console for AIX, integrated file system snapshot, requires POWER4 or newer CPUs. AIX 5L 5.3, August 13, 2004, and of support April 30, 2012, NFS version 4, Advanced Accounting, Virtual SCSI, Virtual Ethernet, exploitation of simultaneous multi-threading, micro-partitioning enablement, POWER5 exploitation, JFS2 quotas, ability to shrink a JFS2 file system. Kernel scheduler has been enhanced to dynamically increase and decrease the use of virtual processors. AIX 5L 5.2, October 18, 2002, and of support April 30, 2009. Ability to run on the IBM Blade Center JS20 with the PowerPC 970. Minimum level required for POWER5 hardware, MPIO for fiber channel disks, ISC initiator software, participation in dynamic LPAR, concurrent I/O feature introduced for JFS2 released in maintenance level 01 in May 2003. AIX 5L 5.1, May 4, 2001. Ability to run on an IA64 architecture processor, although this never went beyond beta. Minimum level required for POWER4 hardware and the last release that worked on the microchannel architecture, 64-bit kernel, installed but not activated by default, JFS2, ability to run in a logical partition on POWER4, the L stands for Linux Affinity, trusted computing base, support for mirroring with striping. AIX 4.3.3, September 17, 1999, online backup function, workload manager, introduction of TOPR utility. AIX 4.3.2, October 23, 1998, AIX 4.3.1, April 24, 1998, AIX 4.3, October 31, 1997, ability to run on 64-bit architecture CPUs, IPv6, web-based system manager. AIX 4.2.1, April 25, 1997, NFS version 3. AIX 4.2, May 17, 1996, AIX 4.1.5, November 8, 1996, AIX 4.1.4, October 20, 1995, AIX 4.1.3, July 7, 1995, CDE 1.0 became the default GUI environment, replacing Motif Window Manager. AIX 4.1.1, October 28, 1994, AIX 4.1, August 12, 1994, AIX 4.0, 1994 run on RS/6000 systems with PowerPC processors and PCI buses. AIX 3.2 1992, AIX 3.1, February 1990, journaled file system type. AIX 3.0 1989, LVM was incorporated into OSF/1, and in 1995 for HP-UX, and the Linux LVM implementation is similar to the HP-UX LVM implementation. SMIT was introduced. IBM PS/2 releases, AIX PS/2 v1.1, 1989, last version was 1.3, 1992. IBM 6150RT releases, AIX v2.0, last version was 2.2.1. AIX v1.0, 1986, user interfaces. The default shell was Bourne shell up to AIX version 3, but was changed to Corn shell in version 4 in view of XPG4 and POSIX compliance. Graphical, the common desktop environment is AIX's default graphical user interface. As part of Linux Affinity and the free AIX toolboxes for Linux applications, open-source KDE Plasma workspaces and GNOME Desktop are also available. System Management Console, SMIT is the system management interface tool for AIX. It allows a user to navigate a menu hierarchy of commands, rather than using the command line. Invocation is typically achieved with the command SMIT. Experienced system administrators make use of the F6 function key, which generates the command line that SMIT will invoke to complete it. SMIT also generates a log of commands that are performed in the SMIT script file. The SMIT script file automatically records the commands with the command flags and parameters used. The SMIT script file can be used as an executable shell script to rerun system configuration tasks. SMIT also creates the SMIT log file, which contains additional detailed information that can be used by programmers in extending the SMIT system. SMIT and SMITI refer to the same program, though SMITI invokes the text-based version, while SMIT will invoke an Aix Windows System-based interface if possible. However, if SMIT determines that Aix Windows System capabilities are not present, it will present the text-based version instead of failing. Determination of Aix Windows System capabilities is typically performed by checking for the existence of the display variable. See also, AOS, IBM's Educational Market Port of 4.3 Bahamian dollars, List of UNIX systems, MAN, Operating Systems Timeline, Service Update Management Assistant, References. External links, AIX and UNIX DW Zone, AIX Fix Central, AIX Forum, AIX User Groups, Submit AIX Requirements, AIX Toolbox for Linux Applications, AIX version 5.3 Documentation, AIX version 6.1 Information Center, AIX version 6.1 Overview, AIX Wiki, AIX ESA V2R2 General Information, IBM AIX Page, IBM Systems AIX Magazine, IBM Electronic Service Agent, AIX Health Check, ROOTVG.net, Independent Portal for AIX and Power, AIX Commands, Tools, Scripts and Explanations, 80-page marketing booklet from 1989 explaining IBM's AIX vision at the time.